Hey everyone, and welcome back to Newegg TV. My name is Paul, and once again we have a special guest here in the Newegg TV studios. This is Jason Calkins. He is the CTO of Dataram. And how are you doing today, Jason?
I'm doing great, Paul. Thanks for having me.
And we're here to talk about a few different things. Specifically, we're here to talk about AMD Radeon RAMDisk. Now, Dataram and RAMDisk, this is sort of a marriage between the two companies, so to speak. You guys have been working together.
Yeah. Dataram is now partnered with AMD, and we've worked together to produce Radeon RAMDisk, which is AMD's very customized version of RAMDisk for the market that's tied in with their memory offerings.
Okay, so we're gonna sort of start off from ground zero here, from the basics. When you're talking about storage in a computer, typically it's separated into two different families. You have volatile storage, which is RAM, or memory, which is right there. You also have non-volatile storage, so to speak, which you guys are probably familiar with, mechanical hard drives, SSDs. And when it comes to storage, historically it's been one of the slower elements of a typical desktop computer system, and it's been getting faster. So SSDs have introduced a great amount of speed that's now available for end users at home. But what we're going to be talking about is RAM disks. Now, when you're taking part of your RAM and you're setting it aside almost like as a separate drive, like you'd have a separate SSD or a separate hard drive in a system, what does that do for you? And I guess the second part is how to do it, but we're going to get into that. So what benefits do you get from doing that?
Yeah, so as you pointed out, we have various tiers of storage in the system, and more as time goes on. We've gone from hard drives to SSDs, a lot of great adoption there. And the benefit is obviously speed. You pay a little more for it, but you get faster. And there's usually like an order of magnitude, 10x faster performance when you move from a hard drive to an SSD. And we get even a greater performance benefit when we move from SSD to RAM disk. So basically, the progression has been that we have more and more memory available for cheaper and cheaper. And your system is not actually utilizing all that memory all the time. You can load up 32 or 64 gigs of memory in these high-end gaming systems, and you're actually only using a small portion of that. So what do you do with the rest? What good use can you make of it? And one thing that we've seen a lot of customers doing is creating large RAM disks. And the reason they do that is to get that intense speed benefit. There is nothing faster in your system for loading and saving data. So if you have something that's data intensive, like video games, video editing, things like that, where you're just hammering or loading large files, giant textures, major AAA games, have these kind of things. If you want to have that seamless, instantaneous experience, a RAM disk is the way to go if you can do it.
Okay, so for folks at home who might have a gaming system or a desktop PC set up at home, if let's say you have 8 gigs or let's say you have 16 gigs, those are kind of common configurations at this time, would you give a personal recommendation? How much of that memory would you say for typical, say you're doing web browsing, you're doing some gaming, how much of that memory would you actually use? And then to follow up, how much of that might you have left over to actually set up as a RAM disk?
Yeah, that's a good question. So typically, we've seen that you're really okay with about 4 gigs for your operating system and simple, straightforward games. You can get a little higher than that, but if you look at your system utilization when you're running your game, you're really not going to see your RAM getting much above 4 to maybe 6 gigs tops.
Okay.
So everything else that you have is relegated and useful for anything you want to put in it for RAM disk. So you can put your gaming system, you can put your games in there, you can put your video files, you can do all kinds of different things with that space because it's really not utilized. And like you said, you're getting a 16 gig kit and you're really only using a small portion of it. So this is a great way to utilize space that you're not otherwise using, and it's a great use for it because it enhances your gaming experience because everything happens instantaneous and seamless. Where even with an SSD, there's some lag time.
Okay, so the software is available for download. It's available in different configurations, and we're going to be demonstrating that as well. Let's talk a little bit about the hardware first off, because we do have some AMD Radeon memory. This is Gamer Series memory. We can see the box for it right over here. 2133 speed. We have a 4x4 gigabyte kit, so our current system is running with 16 gigabytes of memory. Now, going to the memory side, the AMD Gamer Series memory, when you purchase this, you actually can get AMD Radeon RAMDisk as well?
Correct. And we actually have a promotion going with Newegg right now, so that you can actually get a free full version of RAMDisk with your AMD memory purchase through Newegg.
Very nice.
So you get this card here that has a coupon code in the back and lets you unlock the full version of Radeon RAMDisk. I should mention at this moment that Radeon RAMDisk is actually free up to 4 gigs, so anybody can try it out and use it. If you happen to have AMD memory, it actually unlocks free up to 6 gigs.
Okay.
So you get a little more flexibility there, and then if you choose to purchase it or you have a promotion code, you can unlock the full 64 gig plus capacity to use for whatever you need.
Okay, so available in a few different configurations.
Yeah.
If you guys at home are watching this video and you find this type of thing fascinating or interesting and you just want to download it and try it out again, available for free, do we have a website?
Yeah, it's radionmemory.com.
Radionmemory.com. Go ahead and try that out. You can set up to a 4 gig RAM disk, and then you can play around with it, do some of the demos like we're going to show you here in just a moment. And then, of course, right now for a limited time, we're not sure how long that's going to go, but if you do buy the AMD Gamer Series memory, you can get this software for free, which is a very nice value add to purchasing some new memory. Apart from that, like we said, we got 16 gigs set up right now. So let's move from that into the actual software because we do have a demonstration that we're going to set up. We're going to do some synthetic tests, and then we're also going to do some real world tests because whereas it's fun to plug in a synthetic test and see how fast it can actually get, how you actually use this I think is going to be something that a lot of people are interested in, and there's actually a few different ways to use it. So let's go ahead and jump in with some configuration options. So I have my memory installed. I'm loaded into my operating system. As far as compatibility, what compatibility do we have?
All
right
modern versions of Windows. So
all modern versions
8
of Windows.
down to actually XP even.
Okay, so XP and on, you can load up this software and make use of it. So how would you go about, let's see, from step 1, we've just loaded our OS, and how do we load up AMD Radeon RAMDisk?
Okay, so step 1 is to download it from radionmemory.com.
Okay.
And there's actually some videos there, tutorials on how to configure this for each of these particular use cases that we're going to go through today.
Okay.
So if you don't follow everything right this second, I'm not going to go into huge detail. You can actually go to our website, look at the videos, and see step by step how to configure it for each of these applications.
Excellent.
Okay, so we've basically just downloaded the software there, and we're going to go to the configuration utility. And that will launch this really simple GUI. In fact, you're going to see here how quick and easy this is to use. So we pull up this little utility here that has basically a script of what you want to do when you start the RAM disk. So when I click the Start button down here, I want to create a new disk. And I want to, you can specify how much you want to create, how large of a disk you want to create, and there's a message here that tells you how much available memory you have. Okay. And we already did the work of making sure you have just enough to make that your operating system will work and things like that. So you can't use the full space, but it's pretty close to it. And we actually recommend, that you actually leave, again, I'm going to draw a line at 4 gigs. You really want to keep 4 gigs if you're running games. If you're not, you can kind of crank that down to 2, but we want to say 4. Okay. So I'm just going to create a 2 gig RAM disk just for the purposes of quick testing, okay? And we're not going to do any labels or create a temp directory in it. And we're just going to go ahead and create this as a temporary disk. Okay. Now, there are tons of settings in here to create a non-volatile RAM disk, which is one of the most common questions we get asked. So like, do I lose all my data if I turn my computer off? And the answer is no, because we have settings in here that actually dynamically save the data back to your drive as you're using the RAM disk. So when you go to turn off your computer, it saves, if there's any remaining data that's not been saved, it saves that small amount and you go ahead and shut down. When you start up, it immediately creates a RAM disk that's available for use, and then backfills that with all the contents of your RAM drive, so that as you use your RAM drive, it's actually pre-populated and instantly available, which is one of the Dataram and AMD exclusive features for this version of RAM disk. Really handy.
I've actually seen some software before where you load up a RAM disk and let's say you have a 4 gig or an 8 gig or even like a 16 or 32 gig setup, and it's got one massive file that's backed up onto your mechanical or your SSD, and when you load, it's got to load that all into the RAM disk, and it adds a little bit to the boot up times and that sort of thing. So this is actually going to, it'll have that RAM disk there and available right when you load your operating system, and then it's going to kind of dynamically populate that with all the data. And then you also mentioned, like say when you're going to shut down, it's actually going to incrementally save the data to the drive rather than having to back up, say, a 16 gig file or something like that all at once.
Yeah, that's a AMD and Dataram exclusive feature that we actually only save back the things that we change. So if you only if you only change a few game save files or whatever you're doing, a small portion, we don't try to save the entire contents back. We just save what you've changed.
Okay.
And we do that the moment you change it, rather than waiting until the end, which can add a lot of time to your shutdown times if you're having like an 8 or 16 gig RAM disk.
Okay.
It takes a long time to save that off.
So it's going to work. It'll work in the background to make sure your RAM disk is backed up.
Exactly, and that was a great deal of work that we did to make this completely seamless. As much, the user experience is as seamless as we can make it.
Excellent. Okay, and that option is right there. Again, we're just testing right now, so we're not going to save that. But I imagine if you chose that, it would sort of ask you where you want to save that that RAM disk.
You'll get a dialog box asking you where you want to save the file, and bang, you're done.
Perfect.
You're in business. So, and it's as easy as just hitting the start button, and it will install the driver and let you know it was done successfully. And then, of course, you get your autoplay dialog will pop up back here.
Just as if you popped in a new disk or flash drive or something like that, pops up as a usable disk.
Yep.
And it's currently assigned to drive D.
Correct. And that's it. That's all we need to do here. We haven't, there's other settings, obviously, then you can look at our site and check that out. But that's it. We don't even need to do this anymore. We can actually just shut the GUI down, and now we've got our drive created, and we can run our tests. Okay, so speaking of tests, next up, we're going to do some synthetic tests, because when you talk about storing data on RAM as a drive on your computer, let's compare it to SSDs. We can compare it to mechanical hard drives, but those are for mass storage, and there's not much of a comparison. SSDs that I test these days, if I'm plugging in via SATA, the most I'll ever get, let's say sequential reads and writes, say between 500, maybe 520, 530 for some really nice ones. Maybe like a 550 is pretty much the max that can hit. What kind of speeds can we expect from a RAM disk? Well, it depends on the benchmarking tool you're using.
Okay.
But starting with Crystal Disk Mark, which is probably pretty conservative, you can get into the 8 or 9 gigabytes per second.
Okay.
And then if you use even more and more detailed testing tools, we've seen 14 gigabytes per second.
All right.
So quite a bit. And IOPS, in the hundreds of thousands of IOPS range.
All right, and that's 14 gigabytes as in. Well, let's run a test.
Sure.
Let's show some folks real world here.
Let's do. You want to do Crystal Disk Mark?
Sure, we'll start off with that one.
Okay.
If you guys aren't familiar with Crystal Disk Mark, you can Google it. Really simple, easy to use utility. If you just got a new drive or something and you want to test it out, it's really easy to use. But again, this one's not going to be as in depth. So, but easy to use for folks at home. So.
Yeah, and we're just going to run this against the D drive, which we have no data on it yet, so it's basically empty. And we're running all the defaults, and we're just going to run one iteration of this test. And just click all.
All right, so we'll give it just a moment to run, and then we'll come back with the results. All right, so our test is completed, and if you guys are looking at this up close, bear in mind there's no decimal points here. Usually when we're seeing something here, we'll see like a 515.3, something like that. These are gigabyte numbers right here.
Right.
Okay.
Yep, so that's 9 gigabytes per second, because this is megabytes per second. 9,000 megabytes is 9 gigabytes.
It's over 9,000. We have to.
Yeah.
Okay, that's the only meme I'm going to reference for the time being. 6.5 gigabytes per second on the sequential reads. Again, huge numbers, and orders of magnitude greater than you could see with an SSD. We have 4K tests down here as well, hitting just between 700 and 800. I should say, I guess between about 675 to 800 megabytes per second. Again, and these are 4K tests. Using very small file sizes, which is very common for typical day-to-day computer usage. And again, just pull up any one of our SSD videos and compare these numbers, and you can see the difference that you get by going with the RAM disk. So huge speeds right there. But from my understanding, we could actually go even faster than this?
Yeah, like I mentioned earlier, this tool is great as a quick and dirty benchmarking tool. It's pretty ubiquitous and easy to use. In the storage industry, we have another tool called Iometer that we use frequently, and it's an open source tool. It's been used for years, and it's really optimized for the high-end test and enterprise storage.
Okay.
However, it's great for testing super high performance, even on the desktop, because it's got all the bells and whistles you need for testing enterprise arrays. So it certainly works for this kind of stuff. I've actually pre-configured a test here a little bit. I just want to show you. We're going to go ahead and do a 4K block size. Okay. The nice thing about this tool is you have a lot of different options here, and you can configure it all. And I just want to show you some of the settings we have in here. Okay, so we have a ton of tests we can run and all these various knobs and bells and whistles. The test that I have set up right now is for a 4K block size. In fact, I've already edited this to be a 4K, 50% random, 50% sequential, and it's 50% read, 50% write. All right, so it's a real generic test.
Really blend of the all the way from the 4K to the sequential, that's really the kind of the big difference that you often see if you're looking at an SSD or a drive, and they're showing the numbers it can achieve. So this is really kind of a middle of the road blend of all of those tests together.
Exactly.
And now it's running.
Yeah, so I just pressed start, and now it's displaying. These numbers are a little harder to read, but they're also being dynamically updated. This is running live right now. So we're running 436,000 IOs per second at that block size, which is a huge, huge number.
And this is not a test that we've like optimized for IOPS or anything like that.
Nope.
About 440,000. And again, compared to an SSD, which maybe will hit 80 to 85,000 in the specific tests that are designed to maximize the number of IOPS that you can see in a synthetic benchmark. So very, very huge. You can also see total megabytes per second. We're hitting 1.7 gigabytes per second. Yeah, so, and then of course our access time is, I mean, you look at an SSD access time that's like maybe 0.1 or 0.02 or something along those lines. We're at 0.0089, so even access times, which are, I mean, we're getting very specific there, but even faster than SSD. I just have to point that out as well.
Sure. So let's do a throughput test just to see what we can do, sort of a top-end speed test. So we'll go back to our access specifications. I'll remove that one.
Okay.
And let's just create a brand new one. So we're going to go to a full megabyte block size. So it's a 1 megabyte block size. We're going to go to 100% sequential, and we're just going to make it 100% writes.
Okay.
Okay, so that's simple. Everything else is default. That just means we're going to use large blocks. We're going to sequentially write them. This would be something like if you're installing a game or if you're doing video editing or anything like that where you're streaming data. This is like the absolute speed, speed number. This is your speed limit number. So, and then we just add that to our test, and then we can go ahead and start. And so now we're looking at, it's kind of hard to see, I know you guys at home, but it's 15.78 gigabytes per second throughput.
Very nice.
So it's very, very fast. The fastest storage I think you're going to find on your system.
Wait, repeat that number one. 15.8 gigabytes per second. We'll give that just a moment to sort of, yeah, that's huge. Okay, so now obviously we're working with a 2 gig RAM disk right now.
Right.
So this would take, I can't even do my math, like 0.2 seconds or something to fill that up. Now, so now we've shown some of the sort of the theoretical maximum numbers that we can hit with a RAM disk. Let's briefly talk about some of the limitations. Now, we've already mentioned its volatile memory, but we mentioned how you guys have set up your software to dynamically store that in the background. Let's talk about capacity a little bit, because as we mentioned, we have a 16 gig kit here. We've set up a 2 gig RAM drive. I'll find that if you're going for more memory storage, maybe you'll get 16, maybe up to 32 gigs if you're going with 8 gig DIMMs. Fortunately, memory prices have been continually dropping, so it's a lot more accessible for that. So let's sort of transition over to real world use case scenarios right here. If I have 32 gigs of memory, and as you mentioned, 4 gigs is probably what you'll need. Let's give myself a lot of headroom. Let's say I'm going to set up 8 to 12 gigs of that. That would still give me, say, a 20 to 25 gig RAM drive that I could set up. So if I have 25 gigs of storage, for gamers out there, how might this help you if you're setting up a game and you want to really maximize your gaming performance with respect to a RAM disk?
That is an excellent question. So if we look at the Radeon RAMDisk GUI, there's actually a really slick way to manage this.
Okay.
So obviously, you can't put every single AAA game that comes out in a year in 20 gigs, right? So, but it's certainly big enough to run every AAA game that I can think of as a single game.
Yeah.
And the neat thing about RAMDisk is we can actually save multiple images with the RAMDisk utility. So when we go and choose that we're going to save this and load this, we get to specify a file location.
I see.
And I can have, for example, if I'm playing, Borderlands 2 or Battlefield 4 or whatever, I can actually create an image for each of those games.
Very nice.
And it's actually even easier with Steam. So with Steam, for example, I can have my entire library of games, and I can just select which game I'd like to have and move that onto my SSD, and onto my RAM disk, rather. And so you can actually manage that through Steam. You can manage it manually through the GUI here. So it basically lets you utilize it to play the most important game to you at the time, right? You can have that optimized, but if you want to play something else, or something new comes out, you can always put the newest thing on there without losing your old settings and everything else that you've tweaked and tuned just for that one particular game.
So say you have a big mechanical hard drive, you got a big SSD, you can sort of save little snapshots of each game on there, and then just load each of those dynamically to the RAM disk, choose which one you want to load depending on what game you're playing most frequently till 2 or 3 a.m. every night. And then it just loads it up. So it's not even necessarily like you have to do a lot of work to sort of transition back and forth, or you need to go through a different setup and configuration each time. You sort of point those out, and then you just load each one dynamically.
Yeah, for me, I use Steam a lot, and it's really handy because I can just go to my library. If I want to play, I just bought a game, I just install it right to my RAM disk and play it from there. And then when I'm want to move on, try maybe a new game, I can actually keep that image file somewhere, and then go ahead and use Steam to put the next game on. And then Steam is smart enough to know when you've swapped out drives and things like that, so it can actually just point right back. When you re-enable that image, Steam recognizes that it's back online, and you play that game right from Steam.
All right.
So it's really super handy.
Cool. So let's do a quick game demonstration. We're just going to do a quick swap of the configuration because we've been using iometer right here, and then we'll come back and show you how fast these games can actually load. So our game demonstration that we have here is actually a video. We realized briefly that we're running on an iGPU right now, and not quite so good for game demonstrations. Plus, you really need a side-by-side comparison. So this is a quick clip that Jason set up. So what are we looking at here? We're comparing RAID to Radeon RAMDisks?
Correct. So what I did was I basically took a system with a RAID 10 setup, which is with 4 hard drives. We wanted to compare it to one drive, but that would have taken too long. I mean, even that gets boring watching a load screen that long.
That's true, that's true.
So we just basically did a side-by-side demo of load times with Radeon RAMDisk and the RAID 10 drives. And we have a bunch more of these on our website as well.
All right, so this is from the moment you click go, and this is Skyrim, of course.
Yep.
And Radeon RAMDisk on the bottom, RAID 10 hard disks above. As we can see, the Radeon RAMDisk is loaded. So this is sort of an example of the benefit you get from running your games off of a RAM disk, especially if you're playing games that have huge levels or vast open worlds or something like that, times when you have to jump from section to section and needs to load data. It's also going to jump into a Far Cry 3 demo as well, just kind of the same thing. RAM disk on the bottom, RAID 10 hard disk on the top. There you go. Loaded Far Cry in 9 seconds. So some really impressive performance there when it comes to game load times, and a great example of how you're going to get some benefit by running your games off of a RAM disk. And as mentioned with the software, it makes it really easy to do.
Yeah, and as you pointed out, it's not just the initial load times that benefit. It's when you're transitioning. So especially like games like Skyrim, where you're entering a building or going into a space, that's there's this typically a lag time, and the screen goes dark and you wait. Well, with RAMDisk, it's instantaneous, so it's a much more seamless experience, not just loading the initial level. And another thing that some gamers have seen is when you're running competitive first-person shooter games online, for example, your system is going to be ready and raise the flag first because the server's ready to move on to the next level, and it's looking for everybody's flag to go. I've got my level's loaded. I'm synced up. Well, your system's the fastest one, so you typically get your flag up first, so you're spawning first. So if there's a game where there's resources and things like that, you're always usually first in the queue.
So a bit of a competitive advantage there as well. So some great examples of gaming scenarios where the RAM disk might help out. Let's talk about some alternatives to that. We don't necessarily have some demos to show you, but for instance, here we do tons of video editing. Is this another? Is setting up a RAM disk on a video editing system? Is that also going to provide you some huge benefits? Yeah,
that's actually our number 2 utilization of the software today. Okay. So we have a large number of people who actually use it for video rendering, editing. It's basically anything where you have very large files and you're doing a lot of operations on them. It's great for scratch disks, things like that, where you're doing filters and operations on your data, and you're saving and loading large files around. And for 3D, the more and more resolution we're seeing out there, the more and more use you have for a very high bandwidth storage system like this.
Excellent. I would imagine if you could also get, say, your raw media copied over to a RAM disk, and then you're doing, say, you have a massive project with tons of files, you're working with 1080 or even going upwards from that to 2K or 4K resolutions. It's going to be able to load all that data as you're scrubbing through a video file or through a timeline somewhere. It's going to be able to jump. You're not going to have to sit there and wait for that.
Exactly.
Wait for it to jump and wait for the disks to spin up and go to the right place on there. So another great use case scenario for that. Enterprise, of course, is another example here where you're going to get a ton of usage out of a RAM disk. That's almost another video all in and of itself as enterprise usage. So any quick points for enterprise users out there?
Just that we have a commercial version of the software which has a lot of the same features, and it's designed for use in multiple seats in large corporate environments.
Excellent. So hopefully that gives you guys a better example of RAMDisk, how to use it in general, as well as specifically talk about AMD Radeon RAMDisk. Again, available for download. The website one more time.
RadionMemory.com.
RadionMemory.com if you guys want to download that. Check out the AMD Gamer series of memory as well, because you do get it for free along with that. Oops, I almost hit our power supply. So yeah, check it out. It's a really fun tool to play around with, and then you also get a lot of benefits from it as well, whether you're talking about gaming, whether you're talking about using some higher level stuff like video editing, or as you mentioned, enterprise usage as well. So we've been talking with Jason Calkins, again, CTO of Dataram, and thanks again, Jason, for stopping by today.
Thank you, Paul.
And thanks to all you guys for watching. If you'd like to see more tech videos, you can find them on our Newegg TV YouTube channel. Don't forget to subscribe. Don't forget to like this video if you enjoyed it or if you found it useful. And we'll see you all next time on Newegg TV.